In this video, we're going to talk about how we would solve an absolute value inequality. So the most basic would be something like absolute value of x is less than 3, or the absolute value of x is greater than 3. And let's look at a number line, what that would look like. So if the distance from 0 is less than 3, well, then it could be anywhere from less than 3, right? Oh. Less than 3. Gosh, I don't know why it likes to put these weird little things on 3's. Okay, so it would include all these numbers less than 3. 2 works, 1 works, 0 works, right? All those are less than 3. But what happens when we come on the negative side? And okay, so negative 2, absolute value, that's less than 3. But what about negative 4 and negative 5? Take the absolute value, that's not less than 3. So it also, at the same time, has to be greater than negative 3. So it's only these numbers in between here, right, that work. The way we describe that is with an and. An and. That means it not only means that x is less than 3, it also, at the same time, which is what and means, x must be greater than negative 3. This is different than the two parts we did before, because that could be either one. This, it has to be both of them. Okay, so whenever we have an absolute value with a less than, it turns into an and problem. It means it's where it overlaps. And if you remember set stuff, that would be the intersection. It's the intersection. Okay, now let's just look at the number line with, these are not good. Okay, we'll look at the number line with a greater than 3. So if the absolute value of x is greater than 3, it would include all these up here, right? Greater than 3. But what about the negative? I mean, it really includes all those, but it also includes all these that are less than negative 3. And this is not an overlap. It doesn't overlap, right? It's both of them. They're both going to work. I don't need to limit them like I did here, right? I'm not limiting them. I'm using them both. So this is an OR. This is an OR problem. Okay? OR means either one. So it would be we would switch this to two different inequalities by saying, well, x is greater than 3 or x is less than negative 3. So this OR means it's a union. OR is the union. It means either one. So the hard part is that we would often describe this with and when we're using and in the way we use it in the English language, right? Oh, it's x is greater than 3 and it's also x is less than negative 3. That's not the way we use and when we're talking mathematically. When we're talking mathematically, it means they both have to happen at the same time. An or would be what we mean, right? It can be this one or this can be this one. It doesn't matter. It's either one. That's an or problem. Alright, so we can, all the same things that we did before, true. Suppose I have the absolute value of x plus 2 is less than or equal to 7. Then once I have this absolute value by itself, I can switch it to the two equations, right? That's our goal. In order to get rid of the absolute value, you have to make it into two equations. So that would be, well, whatever is inside the absolute value, less than or equal to 7. And this is a less than, so that means it's an and. Don't forget to write the and, because it's going to remind you of what you're going to do. You always are going to have to come back and figure out whether it's an and or an or, even though writing them would be the same. And then you have what's inside, greater than or equal to, so we switch the inequality and we make it a negative. So it's x plus 2 is less than 7, and it's also x plus 2 is greater than or equal to negative 7. We solve each of these. So I have x is less than or equal to 5, and x is greater than or equal to negative 9. Alright, so on the number line, I have my negative 9 and my 5, right? And I want it less than 5. Well, that's going to be this way, right? And I also want it to be greater than negative 9. So that's going to be this way. And I'm looking for where they overlap. So my answer is just going to be the part that overlaps. Now, in these cases, right, it's an equal to, so I'm going to include the endpoints, right? I'm going to go from negative 9 to 5 inclusive. Okay, there's my answer. Every number in there will work in my inequality. Go ahead and choose some, you know, like we could pick like negative 8. Well, negative 8 should work because it's in that interval. So if I plug negative 8 in up here, it'd have the absolute value of negative 8 plus 2. Well, that's negative 6. The absolute value of negative 6 is positive 6, and 6, sure enough, is less than 7. So this is what we have as our solution. Well, let's try one with greater than. So if I have x minus 6, absolute value of x minus 6 is greater than or equal to 2. Alright, well, that means that either x minus 6 is greater than or equal to 2, or x minus 6 could be less than or equal to negative 2. Okay, so once again, once you have the absolute value by itself, you split it into 2, because this is a greater than, this is an or. Okay, now we can just solve each one. So I would add 6 to both sides. I have x is greater than or equal to 8. Or when I add 6 to both sides up here, I have x is less than or equal to 4. When I look at the number line, I have 8, I have 4. Greater than or equal to 8 is going to be up here. Less than or equal to negative 4 is going to be down here. So when it's an or, it's everything. It's not the overlap, it's everything. Okay, so that means my answer would be from negative infinity to 4 union, and this is what the union means, is that or 8 to positive infinity. Okay, there's how I would write my answer. So, just like before, if we have anything else, if we have anything else like this 2 here, we can't do it, right? We can't break it into 2 equations until that 2 is gone. So the first thing you always have to do is get the absolute value to be by itself. So don't try to do any of the things that we've been doing until the absolute value is by itself. Alright, and then it doesn't matter what's inside, we can do 2x plus 5 less than or equal to 8. And remember, it's a less than, so it's going to be the and 2x plus 5 is greater than or equal to negative 8, and then you solve each one. Right, so we subtract 5, and we'll divide by 2. So it's x is less than 3/2. And it's greater than negative 13/2. Another room. So this negative 13/2 and this 3/2. The answers, remember I'm looking for greater than this, but less than this, right? I'm looking for just where these overlap. So it's going to be, and these are equal to, so I'll include the endpoints. So there's my answer. Okay, so the thing to remember is you have to get the absolute value by itself. If it's a less than, you switch it to 2 equations with an and. If it's a greater than, you switch it to 2 equations with an or. And means they have to overlap, or means you use them all. Okay, here's your quiz question for 1.7b. It's the last one for this quiz, and it's absolute value of x minus 5 minus 4 greater than or equal to 3. Write it down, solve it, enter it into the quiz, enter the answer into the quiz. Use interval notation. So you can use for infinity, for the infinity symbol, you can use INF, just the letters INF. And for union, just use the letter U, the capital letter U is the perfect one to use.